Good day, everybody. As Ben said, I'm Ray. All things functions in JavaScript. This is a talk that was born out of debugging and troubleshooting and dealing with some of the weird stuff that JavaScript does. So that's what we're going to talk about today. As Ben said, my name is Riel. I am a developer advocate at 8base. I also organize a lot of different developer things like UtahJS, the 4JS conference, and Random Hacks of Kindness, which is a really cool hackathon where we go out and find not-for-profits that have tech problems that can't solve them, and then spend the weekend hacking away. The other thing to note is that I am Canadian, so if things sound a little weird, this is just how you politely pronounce words. But aside from that, you know, I'm Canadian, so I'm sorry for that joke. So this talk, we're going to go into the nuances of functions in JavaScript. This talk is very example heavy with a lot of audience participation. So I do encourage hand raising, shouting out anything that you want to do to get my attention. That's not a problem. This generally tends to be a fluid talk, depending on how much interaction we do throughout the talk. Sometimes I just keep talking until my time is up. So we might not cover everything, but we'll still have a good time the whole time. And like I said, questions are heavily encouraged. So the first thing I'm going to go through is the very, very basic part of functions, which is creating functions in JavaScript. There are 3 separate ways to create functions. And oddly enough, the first 2 have different names to them. You know, we're used to creating these functions and using the function keyword, but they actually have 2 different ways of assigning them. And the third one we all know as arrow functions. So the first is called a function declaration. This is when we're declaring a function. The second is a function expression. This is where we create it as an expression and we can assign it to something or do other stuff. And the third is an arrow function. Now, function declarations and function expressions are generally treated the same. However, there are a couple of nuances that I will go into. Arrow functions, I generally refer to them as function quirky mode because it's got a lot of little weird things that it does that we'll go through as we're getting along. So again, enough with the slides. Like I said, this is very example heavy, so I'm actually going to be doing a lot of live coding as we're doing this. The first one I want to show about is the differences between function declarations and function expressions. So you can see the top one here is a function declaration. The bottom one is a function expression. Now they're generally treated the same. They have a lot of rules that follow where they follow the same rules as each other. However, there are a couple of differences. The first one being that declarations are hoisted. And if you don't know what hoisted means, basically what it means is that no matter where in your JavaScript you write a function declaration, JavaScript puts it up at the top and creates the function up there. So if you create a function and you call that function before it's actually created, that doesn't cause a problem. Because of the hoisting, the function declaration actually gets put up to the top. The same is not, or it's not the same when it comes to a function expression. So a function expression is created at the point that you actually write it out. So you can't call a function expression before you've created it. I haven't put it in here, but an arrow function works almost the same way as that. The other thing to note about the difference between declarations and expressions is that an expression can actually be called as an anonymous function. Now, what does that mean? You can see here in our expression that we haven't given the function a name. We just say function and do the parentheses, and we can actually call that function directly. So by putting our parentheses there, we can call the function directly, and we don't actually have to assign it to anything. We don't have to declare it. It gets created and called, and then it's pretty much gone. So now this is 8base great, you can see, is saying it's not a function, and that's because we've actually just created the function and executed it, and now the result is undefined. It's basically nothing because that is, actually I got to do it this way, console.log. So you can see that this is undefined because that function isn't returning anything. The same cannot be done with a function. If you try to do that with a declaration, it just gets angry and yells at you, as we're all used to JavaScript yelling at us for the problems that we do. So those are the main differences between the two. Everything else that we execute after this operates pretty much the exact same. So let's go into the first section, which is the keyword this inside of functions. If I execute this, what do you think the result is going to be? Just yell it out. Undefined. Undefined? Anybody else have a guess?
Global object.
Window, global object. So when executing this inside of a function, the result of this is global. Now, global can be different depending on what you're working with. Here, with Node.js, you can see that global is its own object that Node.js creates. If you're inside the browser, this will become the window because that's what the global object is for a browser. So depending on what's executing, this can be different, but it's essentially the global object for the context of which is being executed. Next, this inside of a function used with the new keyword, which creates a constructor. What do you think the result is going to be logged out as?
An object.
The function. Perfect. So we see that console logging this inside of that. We see the object itself, the function itself, which is find out. Next up, we have this inside of an inner function inside of a function. Now we've already learned some rules, so what is the answer to this? I want you to make the guess based on the rules we've known already. Global. Right? We've still got the global object. Perfect. This inside of an inner function inside, this inside of a function that's being executed as a constructor. Find out? Nope. So this inside of a function is a global. It doesn't matter that it's being executed inside of an object. It's still considered to just be global. If you want to get around that, and you want to actually access this inside of that inner function, you need to assign it as a method of the function itself. So here you can see I do this dot inner function equals function, and then when I execute, I actually get find out as the result of this concept, this variable. The other way to do it is in an object literal. So this inside of an object literal will actually be the result of the object itself. So if you're assigning it to an object, you're essentially doing a this dot for that object, and that's why this becomes the object itself. Finally, strict mode. Does everybody know what strict mode is? Okay. Strict mode is this attempt to make things a lot more aligned, which kind of works, and nobody ever actually uses strict mode. But this inside of strict mode, what do you think that would be? Undefined. So inside of strict mode, the global object essentially doesn't matter to this, and this just becomes an undefined. Now let's go into quirky mode, which is this within an arrow function. So what's this inside of here? Undefined. Undefined. Let's give it a shot. It's an empty object. That's really weird. Inside of the browser, this would actually become the window object. Node.js makes things a little weird by how it defines this. So let's go to the next one, which is this inside of the find out function. If we execute that, we get global. So why is this happening? Things are getting weird already with the arrow function. It doesn't make a whole lot of sense. How about this inside of a constructor? What do you think that one is? Any guesses? Don't be shy.
I think it would be the find out object.
So you cannot use an arrow function as a constructor. Now, the reason for this, and the whole reason why things are getting weird here, is because the way that an arrow function works is that an arrow function doesn't define its own execution context. It only takes the execution context of the function within itself. So that's why in 2.1 that I showed here, the result was an empty object, because for some reason, if I log out this from Node.js, it's an empty object. Now inside of the browser, this at that level is the window, but Node.js for some reason creates an empty object for this inside of the global, like the main context. And the same thing in here. So because the arrow function is inside of the findout function, it's taking the this keyword from the findout function, which then equals the function itself. And then finally in here, because it takes the this context from outside of itself, it can't be used as its own object. It can only be used as a function. So as a result, if you want to use this, another way to use this inside of a function is by creating an arrow function. Now the benefit of using arrow functions in this context is that that function, that inner function that you're seeing there, essentially becomes a private function. Because if you're using this dot inner function, then anybody who's created that findout as a constructor can now use that function, can reference it and say findout dot inner function. So by using an arrow function, you still get access to the this keyword in the context that we want, but that function stays private. And then finally, the same in here, if you look, the this keyword inside of an arrow function that's assigned to the object is an empty object. And the reason why is because it's taking the context of the function within itself. So because person is not an object, it doesn't have a scope, it takes the outer part of that object, which is the empty object that node gives. Clear as mud? Perfect. Now, a lot of times when I do this talk, people will start asking questions like, what happens if you do this? If you have that question, feel free to ask it, because then I'll just come over here and we'll live code and find the answer out ourselves if I don't know it. If I do know it, I'll tell you, and if it's going to come up later in the talk, I will tell you to be patient. Okay, so we're all aware of how the new keyword works, right? If you log out a function like this, you get an undefined because there's nothing that's returned. If you log it out as a new, there you go, you get the actual function itself that gets returned from a new. However, some things to note about that is a function that has a return variable inside of it. What do you think gets logged out when you do a new with that function? Sorry? Check out 8 base? Nope.
Depends on what you're returning.
It's the function itself. It actually does depend on what you're returning. So this logs out checkout 8 base. Now, if we look at this next one here, where we return this message, we get the object. So the way that it works is that if you're returning a simple, a primitive value, so if you're returning a string, a number, a Boolean, that will be ignored, and the return of the constructor will be simply the object itself. If you're returning a complex value, which is like an object or an array, anything that's not considered to be a primitive value, the return from that constructor is the complex value that you've returned. So the whole point of this talk is that when you start coding functions and you get really weird issues that you're not aware of, hopefully you'll be like, oh, right, yeah, that talk, something weird happened, instead of spending the 40 minutes that I spend trying to figure out these problems in the first place. Finally, a couple of things to note. With a constructor, you don't need to put parentheses in order to call that constructor. If that constructor doesn't have any parentheses, you could just say new log result without calling it as if it was a function, and that'll work totally fine for you. Lastly, there is a variable called new.target. So if you're calling a function, you can actually check new.target. And what happens is, if the function is called by itself, not as a constructor, then new.target ends up being undefined. So if I were to actually log out new.target here, you can see that we have an undefined. But if I were to call it with the new variable, then we actually have a value in there. So by using new.target, you can actually have a function that can act both as its own function as well as a constructor, and you can figure out which one, in what context it's being called. All right, here's another one. Arguments. What do you think happens when I log out arguments? Just a variable that hasn't been created yet. Typically, and I'm moving over to run.js because Node is weird in how it's doing things. Arguments, it'll tell you it's not defined because we haven't created a variable called arguments. In Node.js, it's a little weird because they create their own arguments variable for some reason. However, arguments inside of a function doesn't return undefined. So even though we haven't defined arguments, we still get something back. And what we get back here is what's called an array-like object. Really weird name. Just by looking at this, we can't see too much, but if we go here and we actually call a function that has values, you can see now we have this, which is an arguments object that has a checkout and 8-base. Now, it's a little difficult to see here because of how Node.js runs that. So if I look over here, you can see this is what we get back, which is kind of weird to look at. So it's an object, but the argument, or the parameters of the object are 0 and 1. So it's an array-like object. I'm not 100% sure why they went with an array-like object instead of an array. One of the big things is that there's this callee that gets attached to it, so you can figure out who called the function. That being said, callee is deprecated, and they're eventually hoping, well, they won't take it out because that's how JavaScript works, but it's a deprecated variable that tells you who actually called it. So you can see here we have two variables, we have two arguments, first and second, 0 is checkout, and 1 is 8-base. So why does this argument exist though? Because we have the first and the second, so why would we need it? So the reason why arguments exist is for something called variadic functions. So you can see here we have a function that has a first and a second, but we're calling it with 4 parameters. Now, have you ever wondered why you can have some of those functions where you do like a console.log and you just keep giving it arguments and it just keeps working no matter what? It's because of variadic functions, because of the ability to access an arguments function and actually be able to access all of the parameters regardless of whether or not they're defined. Cool things to note about this arguments function, is that you can make changes and the changes will propagate. So you can see here I'm turning the first parameter into try, and then when I log it out, you can see that it's changed into try. Now the important thing to note is that this only works with simple parameters. So you have 2 different types of parameters and functions, and we'll go over the complex parameters, but it only works with simple parameters. So here you can see we have a default parameter for first, and even though we're trying to change it, it ends up getting changed, but the arguments object doesn't get synced. It still keeps the old value of check. So that's the same whether you're using default parameters, REST parameters, or destructured parameters, which is everything that we'll go into before. What am I on? 4.7? Yeah, so another thing to note is that when it comes to strict mode, it will never sync the arguments object. So if you're in strict mode, regardless of whether or not you change that parameter's value, the arguments object will always remain the same. Cool. Arguments inside of an arrow function. Nothing? I'm glad people are just yelling things out now. That's exactly what I'm hoping for. Yeah, so here, it's supposed to be nothing because of Node.js. It's a dumb thing that Node.js creates. But once again, arrow functions don't create their own execution context, and therefore arguments is only relevant to the function that within that, where that arrow function is contained. So it follows that same idea. So yeah, that's what we're seeing right there. If we have an argument here, it doesn't matter that we passed four different things into that inner arrow function. Because the outer function had no arguments passed to it, it's basically the arguments are 0. All right, next we're going to go into the return keyword. So we all know what return does, right? You say return and it gives back that information from the function. Cool. What do you think is going to happen here? Undefined. So does everybody know what, does anybody not know what ASI is? Exactly. Yeah, people don't know. ASI stands for automatic semicolon insertion. So you know the big, great debate about whether or not semicolons are necessary in JavaScript? ASI makes it so that they're not necessary in JavaScript. Now you can make the argument about whether or not you put them in there, and you'll be wrong. But the point is that ASI exists so that you don't have to put semicolons inside of your code. Now, the way that ASI works is that return is the end of a line. So if you're not passing anything in, it's going to put a semicolon right there, and that's why you end up with undefined. And any future code won't get executed. If you want later lines to get executed, you can just use parentheses, and that keeps it going as if there was no semicolon there. So using return without actually returning anything, why would that be useful at all? It's great to be used as an interrupter. So if you're in the middle of a function and you want the function to just completely stop executing regardless of what code is put after it, that's when you use return by itself. So here you can see we have a function that executes counts, but if it reaches 5, then it'll stop executing. So you can see we have 1a, 1b, because it comes out to b, 2a, 2, 3, 4, and then we get to 5a. It executes 5a, but our count is now 5, so we've interrupted the function completely, which means that 5b will never get called, and then c just never got called at any point. So return is actually really good to use as an interrupter. You know how sometimes you'll create like an if statement and then have if, and inside of that you'll have a big block of code and then otherwise nothing. You could just do an if checking for the opposite of your conditional statement and just return if that value is true. And then you don't have to have the curly brace going all the way down and two spaces per tab block trying to figure all that crap out. So it's great as an interrupter. Now, this here is an arrow function, and you can see we are not using the return statement. However, we still get checkout 8 base. So arrow functions can do something that's called implicit returning. And implicit returning basically means that if there's only one line of code that's being executed for that arrow function, you don't have to say return. You just execute that line of code, and whatever the result of that line of code is, that'll be returned from the arrow function. So it's really great for writing a quick function to do something really fast. That being said, if what you're trying to return is an object, you're screwed. The reason why is because JavaScript interprets that open curly brace as the start of your function. And therefore, you're not going to be returning that object. You're simply going to be executing a function that assigns a message variable that never gets used. I don't know. For some reason, it lets that get executed, but the result is undefined because it won't do an implicit return here. So the solution to that is, once again, parentheses. If you want to return an object, you can just put parentheses around the object, and because we're using parentheses, an implicit return happens, and your object gets sent back. So there are a couple of exceptions that I'm going to detail here where return does not return what you think it returns. The first is a generator function. If you don't know what a generator function is, that's fine. They're useless, and nobody ever, no, I'm kidding. They are useful. They're just a little complicated, and there's only there's like a handful of use cases where they're useful. But what happens if you've got a return inside of a generator function is return doesn't actually return the value there. So the way a generator function works is that when you call it, the first thing that gets returned is a generator object. And a generator object allows you to, so the way a generator works is that it allows you to pause execution inside of the function. So you can see here we have more lines of code with the keyword yield. And then we have more lines of code here with the keyword next. So this generator object takes gives you that object and gives you this next function. When you call this next function, the function will start executing at that point and will stop at the first yield word and return the value that's after the word yield. So you can see here the first thing that's returned is the object with the word value and the word done. So you're not even getting back the value that you put in, you're getting back an object that has the value that you put in. So every time yield happens, you can call .next again, and you can keep executing until it gets to the next one. This is a great use case for pagination. If you're having to deal with pagination of large data sets, generators can become very useful with yield and loops, and it's quite interesting. But at the end, the final a return inside of a generator function is the final result that will come from a .next. And even then, you're not getting the value back directly. You're getting back an object where the value is the return, and then done is equal to true. And you know that the generator has reached its end. Ah, good. You guys are awake and getting involved. I like that. Nothing. You get back an undefined because it's done executing the function.
What is the asterisk next to function?
So this asterisk right here is actually what defines it as a generator function. So if you put asterisk next to the keyword function, and it's got to be right next to the keyword function, I think. So even if I do potato here. Yeah, exactly. So it's got to be next to the keyword function in order for it to be labeled as a generator function. But with that, your result back from calling the function is a generator object that you then use to iterate through the generator. If you didn't know about generators, I mean, it wasn't the point of the talk, but everyone seems to learn what a generator is at this talk. So. The other case in which a return isn't actually what you get back is an asynchronous function. Because when you execute an asynchronous function, what you're actually getting back is a promise. Async and await are what's called syntactical sugar, which is just a nice way of saying it's more pretty than having to deal with promises. So by calling an asynchronous function without the keyword await, you get back the promise. And then you have to deal with the promise and handle its resolve function in order to actually get the value back from the execution. However, if you use the keyword await, this is JavaScript's quick way of dealing with the promises associated with that function, and that will get you back what's returned inside of the return. Clear as mud to everybody? Perfect. All right, let's move on to destructuring. So, destructuring is actually a really cool way that gives you the ability to pull values outside of an object that's passed in as a parameter of the function. So if you look here, I'm calling this getName function and just passing in a person object, just the whole object, because I don't want to have to deal with pulling the name out, blah, 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 all that junk. So I pass just an object, and then up here in the function, you can see I don't have to zoom this in, right? With a giant movie screen, I'm assuming you all can see what's going on. Okay, so because of those curly braces, what I'm doing is called destructuring, which means I am pulling the first name variable and the last name variable or parameter out of that object, and then I'm able to use those specifically inside of the function. So I don't have to just accept a person object and then do person.firstname, person.lastname. I can use destructuring to pull the values out that are just the only values that I care about inside of getName. Here we go. If you want to rename those variables, you can, except it's really weird because it's almost the exact opposite of what we're used to doing in assignments. Here we're doing the exact same thing, but we're naming them first and last. And if you can see, it looks weird because in order to name variables in destructuring, you pass the value first, followed by a colon, and then the name that you want to give it. Does that feel dirty to anybody else, or is it just me? It's inappropriate, right? I don't know why they decided on doing that, but it makes me feel bad. But that's a way to name them. Another cool thing, did I execute that one? Yeah, that works. That's my code. It's always going to work. Another one is that you can actually destructure objects inside of objects, which is really cool. So here you can see I have a person with a first name, a last name. I want to give a signature, which includes the position and the company. So what I can actually do is do first name is first, last name is last, and then go inside of the company info object within the object, and I want the name, which is the company, and the title, which is the position, or which I'm going to name position. And then I can use all of those pieces and just return the signature. Cool, huh? The other thing to note about destructuring is that you can do this with arrays as well. So if you're passing in an array, you can use the positions of the arrays in order to destructure into parameters. So here, we're going to multiply two numbers together, and we have the first and the second, so we pull those out as their own values, and then we can use them as if they were variables instead of pieces of an array. By the way, destructuring is not limited to function parameters. You can actually use destructuring in any part of the JavaScript code, but this is one of the, destructuring is one of the complex parameters I was referring to before. Remember when I said that the arguments object, if you change a simple parameter, then the arguments object will get synced. If you change a complex, it won't. This is, if you're using destructuring and then you're trying to change those values, the arguments array-like object will not get synced with the changes that you've made. Next to see here is REST parameters. So this is a normal function, and how it works, you give two parameters and then you just work with them. REST parameters give you the ability to access parameters that were not defined. Sounds a little familiar, right? By doing a ... what you can do is you can get access to the other parameters that were defined without having access, the parameters that were defined as part of it. Why is it necessary that you figure this out and how they're different from the arguments object? We'll find out in just a sec. I just realized it's a later one. So if you pass less parameters, then having a ... others, then that's just an empty array, which is really great. Means things don't break easily. One thing to note about REST parameters is it has to be the last parameter. You cannot have it in the middle because JavaScript won't understand it, you shouldn't understand it. It doesn't make any sense to ask for all of the middle parameters except for the last one. That's just weird. Code a better function if you're going to do that. Now, why would we do this? Or how is the REST parameters, how did my emojis end up there? That's weird. How are REST parameters different from arguments, and why would you use one over the other? So one of the big differences that you can see here is that REST parameters, let me move up like that. So arguments is an array-like object. So it's a weird object that it created. You have 0 for one name, 1 for another name, but it's not an array. So if you want to work with the REST parameter instead, you get access to all of the array functions that you're used to, things like map and filter and reduce, all of the array functions that sort all of those capabilities. By using REST parameters, you get access to that. If you're using the arguments object by itself, those aren't part of that object. The only thing that's part of that object is a length parameter that tells you how long it is, and a callee that's deprecated and you shouldn't touch anyway. What am I on? 7.6. Right. So another thing to note is that one of the big differences between the two arguments and the REST parameter is that arguments contains the first two values. Right? It doesn't matter whether or not they're defined. You get everything inside of there. So here you can see with arguments, we have to start at 1 because we know that, we have to start at 1 because we know that 1 is the position. So we don't want to use 1 inside of our getting characters here. We have to start at the first value, not the 0 value. Whereas with REST parameters, we don't have to worry about that because we already have the defined parameter separate from the rest of the values. So if you have a case for a function in which you want something defined and then a whole bunch of other stuff, Using a rest parameter allows you to separate those two things from each other, logically. It's important to note that you can use rest parameters with destructured parameters. So here you can see I'm calling this getName, and with this getName, I am pulling out the first name and the last name, and then I am actually taking all the other properties of that object and putting it into others. So if we log out others, you can see that the company and the title are inside of this others object, except now because we're destructuring an object, or we're doing rest on an object instead of an array, it's an object instead of an array. And once again, rest parameters works outside of function parameters as well. You can use this in normal JavaScript code, but in the context of a function, you can use this within the parameters that are passed. Next is default. If you've not used this before, it can be very valuable. What it does is it allows you to specify a default value for a parameter. So here you could see I've got a function called square or more, which basically gives me the ability, if I want to do cubing instead of squaring, then I can do cubing and get back the right value. But I don't have to pass that parameter in. I could just pass in the first parameter, and it'll work fine. It'll have a default value. It does work with structured parameters. So you can see here that I can assign default values. So if the object that's being passed doesn't have exponent, then I still have access to an exponent value here in the destructuring. The other cool thing to note about a default parameter is that you can reference a previous parameter, which seems a little weird. But here I have this function called, do I want it to exponent a value or itself? So if I do 3 and 2, then I get 9. But if I don't pass it in, then it'll actually use the first parameter here, number.
So is a function call if you explicitly say comma undefined, does it use the default or does it break it?
You're talking about here? Or, oh, when I call it?
When you call it.
That's a good question. I think, I'm going to answer it now, but I think I've got an example later that actually does answer it already. I do, and you'll see it. But here, so what it does is if you're passing in an undefined, it'll still use the default value. It won't break. The other thing, you know what? I'm going to do a test here. I haven't done this before, but let's do this. I don't know whether or not it will make sense. There you go. I tried to use a rest parameter with a default parameter, and it's angry at me. So you can't default a rest parameter. It's good to know. So the last type of function to cover are getters and setters. So these are actually pretty interesting. A get function is a function that you can add to an object literal that will allow you to treat that function as if it's a property. So here you can see I have this get name, and what it does is it pieces the first name and the last name together with a space, but I don't have to call it as a function. I'm calling it as if it's a property of the object, but it still executes as a function. The things to note about that is, number one, you are not allowed passing any properties to a get function. If you try to do that, it will be angry at you and tell you you're not allowed having any formal parameters. Another thing, or next up, we have the set function. And the set function is basically the exact opposite. It allows you to use a function to do a set and it operates as if it's a property. So I could do person.name equals Brian Rinaldi, and it will actually execute the function so I can piece it apart into first name and last name. And then you can see that the object is what we're expecting there. So for a set, the same way as a get, you are not allowed passing in. You're not allowed passing in more than one value. You can only pass in one value. So if I tried to execute that, it would be angry with me. Also, if I tried to pass in no values, it would be angry with me. So you have to pass exactly one value into a set, which can be complicated and annoying sometimes. But the good thing to know about that is that it works with complex parameters. So here you can see we have a default. So if I pass in, and this was the example I was mentioning there, if I pass in an undefined to name, I can have a default and it will still work. It'll still operate with that default parameter. At the same time, you cannot use rest parameters with a set, which makes sense because you're not allowed passing more than one parameter to a set anyway, so it doesn't make sense to call to have rest parameters. That'll break your code. But if you're trying to pass more values in, you can do destructuring with a set parameter. So you can pass in a full object to an assignment here, and it'll actually break things up, and it'll work the way that you're expecting with destructuring. So by calling that, we still get the value that we're expecting back here. The final thing to note is the arguments object. The arguments object, what did I just do there? The arguments object does work inside of gets and sets. So with a set, you can get access to the object. It's a little weird because you only have one argument. With a get, you still only have 0 arguments because it's a get. But arguments does work inside of it. So if you have some unknown way to work with arguments inside of set and get, for some reason it follows that. I'm over time. Does anyone have any questions? No? Perfect? All right, good, because they're going to yell at me. But anyway, this was all about functions. The other thing to show, here we go, enough with the slides. There you go. Thanks for listening. I won't take your questions because I'm done, but scan that and you get access to me as well as all of the base stuff. Thank you very much.